Welcome back to the deep dive. You've handed us a stack of sources that, well, they promise to shortcut the future. And today, we're plunging into a technological vision that aims to fundamentally change the interface between humans and AI.
It really does.
We're talking about embodied intelligence that follows you across every screen, every device, and every location.
That's right. We are analyzing the documents surrounding OpenHuman.ai. And we've been given everything from the overarching product strategy, what they call the App Store for digital humans.
Which is such a great name.
It is. And it goes all the way down to the highly specific system architecture blueprints. It's an unusual level of detail, I have to say, which suggests they are very, very confident in their technical moat.
I find that core concept, App Store for Digital Humans, incredibly compelling. It just immediately reframes AI from, a service into a personalized, purchasable entity. So our mission is clear. We need to peel back the layers and understand exactly how OpenHuman.ai is positioned to achieve this global platform status. We have, I think, two major technical challenges to unpack here. First, the breakthrough in solving what they call the final bottleneck of natural human movement and gesture, which has plagued digital avatars for years.
And second, and this is maybe even more important, is the architectural challenge. How did they actually build a system that's capable of real-time cross-device context synchronization?
Right.
We are looking at the foundation for truly ubiquitous, persistent digital companions that maintain a single, unbroken relationship with you, no matter the screen size or where you are.
Precisely. We're aiming to move beyond the superficial summaries and really get into the engineering and the marketplace decisions driving this global first platform. So let's jump right in by looking at the technology that set the stage and why, even with all those components ready, something was still missing.
Okay, so the sources open with this really brilliant diagnosis of the current tech landscape.
Yeah.
They argue that the world has been, around 80% ready for fully realized digital humans for the past, half decade.
Right. But the key is that those foundational technologies develop simultaneously but separately.
Exactly.
They call this the convergence of three massive solved revolutions. It's the perfect analogy, I think, for building a digital human. We built the brain, the voice, and the face, but completely forgot the nervous system.
That's a great way to put it. The first and the most obvious one is intelligence and conversation. This is basically solved by the large language model revolution.
The LLM revolution, sure.
We're talking about the capabilities shown by the big foundational models, complex reasoning, natural language understanding, maintaining long-form conversation context over dozens, even hundreds of turns.
Right, and accessing huge knowledge domains.
Exactly. The sources are really clear on this. The digital human is no longer unintelligent when it comes to understanding and responding.
And that's a critical psychological hurdle cleared, isn't it? If the entity can't carry on a meaningful conversation, the whole experience just falls apart, no matter how good the graphics are. The brain is finally, you could say, capable of being a genius.
Right. Then next we have voice. This challenge is also, for the most part, solved through modern text-to-speech systems. TTS.
Oh, absolutely.
You've got providers like 11 Labs, Azure Neural Voice, and they've introduced hyper-realistic voice synthesis. These aren't the flat robotic voices from, the early 2010s.
Not at all.
They deliver natural intonation, they have emotional awareness, and they can even offer near-perfect voice cloning.
So if the brain is smart, the voice is expressive and nuanced, it sounds human, it just eliminates that barrier of feeling like you're speaking to a machine. It adds that emotional layer you need for genuine companionship or, service.
And then the third solved piece is appearance. This is really the triumph of computer graphics.
Unreal Engine, MetaHuman, all of that.
Exactly. Through those tools and advanced 3D scanning techniques, we've proven digital humans can look photorealistic, down to the level of detail like subsurface scattering and individual pores. They can be visually indistinguishable from a real person on a high-res screen.
So we have the genius brain, the perfect voice, and the photorealistic body. But, as you noted, OpenHuman identifies this persistent 20% gap. If these components are all ready, why are most digital assistants still either a flat voice icon or this stiff, awkward avatar? This brings us to their core problem statement, which they call the final bottleneck.
And the bottleneck is defined as natural synchronized movement and gesture. It's not about the visual fidelity of the skin, it's about the uncanny valley of movement. Current systems just fail to make the avatar move naturally and spontaneously as it speaks.
Okay, can you elaborate on why this specific problem is so much harder to solve than the other three? It seems deceptively simple, right? Can't we just link a word to a hand movement?
That's the trap. That's what everyone thought. But the relationship between speech and gesture in human communication is profoundly nonlinear. It's not a simple map. If I tell you, I have 3 points to cover, the act of me raising my hand and showing 3 fingers isn't just tied to the word three.
Right.
It's tied to the whole semantic structure of the phrase, my emotional state. Am I excited or am I giving a furious warning? The rhythm of my voice, the prosody, and the timing of the gesture itself often comes just before or is perfectly in sync with the word.
That makes perfect sense. I mean, think about giving bad news. If you say, this is going to take a long time, your shoulders might slump a little, your head might tilt, and your hands might come together in this kind of self-soothing gesture. None of that is directly dictated by the word long.
Exactly. Traditional solutions failed because they either relied on expensive, non-scalable motion capture mocap data, which you just can't deploy in a real-time system,
Not a scale, no.
or they relied on canned looping animations. And the result is what we see everywhere now. Digital humans that look stiff, repetitive, or, as the sources put it, completely soulless.
Yes, that soulless feeling.
They just lack the spontaneity and the coherence that you need for long-term, comfortable interaction.
So OpenHuman.ai saw this fragmented landscape genius AI, perfect TTS, photorealistic rendering, and they realized the missing piece wasn't another foundation, but the central nervous system connecting them all and specifically solving that motion problem.
That's their triumvirate approach.
Yeah.
They built the platform that provides the standards, the marketplace, the infrastructure, and the software development kits, the SDKs. But the true technical moat, the secret sauce, is the proprietary runtime AI that's specifically engineered to solve that real-time, low-latency movement problem. It turns these disparate technologies into a single, unified, living entity.
And that sets the stage beautifully for the commercialization side of the platform, doesn't it?
It does. If Section 1 established the technical need, Section 2 really establishes the commercial opportunity. OpenHuman.ai recognized that the only way to scale the number of digital humans you'd need to populate this new ecosystem is to open it up to creators.
I really appreciate the clear analogy they provide here. You know, if the App Store defined mobile software and the Unity Asset Store defined reusable 3D components, then OpenHuman.ai is positioned to define this whole new category of interactive embodied AI beings.
Right.
The goal is to move past these static models and provide digital humans that truly live, talk, gesture, and remember.
And this leads directly to the structure of the ecosystem, starting with the heart of their strategy, the creator. Their value proposition here is, well, it's almost revolutionary, particularly for artists and smaller AI teams. Build once, sell everywhere, earn 70%.
Okay, that 70-30 split is huge. It immediately signals a focus on rapid growth and getting developers on your side. But let me challenge that for a moment. OpenHuman is promising global sub-100 millisecond context synchronization, low latency motion AI, a global marketplace, payment processing. That sounds like a massive continuous infrastructure cost. How does a 30% cut sustain that colossal global compute load?
That's an excellent and a necessary question. The sources suggest 2 key answers. First is scale. They are betting on massive transaction volume, where 30% of a billion microtransactions is vastly more profitable than 100% of, say, 10 large bespoke contracts.
The volume.
The volume game.
Yeah.
And second is standardization. By enforcing platform standards like those ARKit blend shapes we'll get into later, they dramatically reduce the complexity of the underlying infrastructure. They aren't trying to support 1,000 different rendering pipelines. They mandate one, and then they optimize the hell out of it.
I see.
That efficiency is what allows the 70-30 model to become profitable at scale.
So the creator focuses entirely on the unique high-value components, the personality, the look, the unique behavior, and OpenHuman just shoulders the cost and complexity of the, the non-differentiating but absolutely critical infrastructure.
Exactly. This democratization is key. It allows individual artists or psychologists or niche domain experts to create these highly specialized digital humans without needing their own dedicated global IT department.
Okay, so moving to the second role, the user. Their value proposition is tied directly to persistence. One assistant, everywhere you go. This is the anti-fragmentation promise.
It has to be. The user experience should be seamless. If you purchase a digital human, whether it's a productivity assistant or a language tutor, it has to be the same entity with the same accumulated memory, the same learner preferences, and the same relationship history, whether you access it to your phone, your car, or your desktop.
Right.
That continuity is what transforms the AI from just a simple tool into a true companion.
And finally, the platform itself, OpenHuman.ai. They take that 30% cut in exchange for the core value proposition. Enable the ecosystem, take 30%.
And for that, they provide the marketplace, the payment rails, the global sync infrastructure, the SDKs, and crucially, that proprietary runtime AI that solves the motion problem, which no creator should ever have to build themselves.
So to really understand what a creator delivers, we need to look at what makes up a purchasable digital human. They frame it as a trinity of components.
That's right. It starts with the first one, personality, or the brain.
The intelligence layer.
This is where you link to an LLM endpoint, which the creator can either host themselves for total control or manage through OpenHuman's infrastructure. The key inputs here are the prompt rules that define the persona. Always speak formally, use historical references, and the specific knowledge domain, whether it's medicine or ancient history or legal advice.
Okay, makes sense. Second is appearance, or the body.
This is the visual asset package. The 3D model, the high-res textures, the skeletal rig, and the platform enforces standardization here, particularly around that crucial facial animation system, to make sure the motion synthesis engine can correctly drive the avatar.
And the third piece, which they often refer to as the soul, is behavior.
Behavior is the glue. It defines the interaction logic, the context awareness, the emotion rules. For instance, a creator can define a rule like when the user is flagged as stressed in the context sync data, reduce gesture speed by 20% and lower pitch, transitioning into an empathetic mode.
Wow.
This is where the creator translates those complex personality traits into actionable physical responses.
So the core takeaway here, and it's repeated in the sources, is that creators aren't just selling files or code snippets. They're selling a highly optimized, integrated experience, a persistent, functional entity that depends entirely on the OpenHuman platform to make it move, remember, and appear everywhere.
Exactly. And that 70-30 model really hinges on lowering the barrier to entry so dramatically that even a single artist or developer can publish a world-class digital human. And to do that, OpenHuman provides a whole suite of free professional-grade tools.
This is the democratization play. I mean, if only large studios using million-dollar mocap systems can create these entities, the ecosystem just fails. So what specific tools are they providing?
They start with the asset library. This is the foundation. Free base meshes, male, female, and neutral, with high-quality topology, ready-made textures, and a standardized skeleton rig. And crucially, they mandate compatibility with the industry-standard 52 ARKit blend shapes.
Okay, we've mentioned those 52 ARKit blend shapes a couple of times now. For anyone listening, what exactly are they, and why are they a mandatory standard for OpenHuman?
Right. Think of a blend shape as a deformation target for a 3D model. If you want a character to smile, you need to tell the software exactly how the vertices of the face move to form that smile. Apple established the 52 ARKit blend shapes as the de facto industry standard because they cover the full range of human facial expressions.
So everything you need for speech and emotion.
Everything. The basic phones you need for accurate lip sync like ooh or but also the highly nuanced micro-expressions like the wrinkle around your nose when you're disgusted or the slight raise of an inner eyebrow when you're concentrating. By enforcing this standard, OpenHuman guarantees that every single digital human, regardless of appearance, can be driven by their proprietary high-fidelity facial animation pipeline.
It's quality control across the entire marketplace.
Exactly. It's standardization leading to quality at scale. Next, they provide the Creator Studio.
And this is web-based, right?
It is. It's a comprehensive web-based environment. This is where creators manage the appearance and behavior. It features a full 3D editor, a texture painter for adding custom details like tattoos or makeup, and an animation timeline where they can manually override or fine-tune the gesture rules.
And being web-based just maximizes accessibility, no complex installs.
Right. And then there are the advanced wrapping tools. This solves the problem of transitioning from a custom artist model to the platform standard.
This sounds important.
It is. This is where serious industrial technology meets democratization. OpenHuman integrates tools, and they cite ZWrap-RDS, which is a leading software in this space, and they make it available to creators. The problem is that while you need the standard skeleton, artists want to create unique faces. The wrapping tool automates the process of fitting a highly detailed custom-scanned 3D face onto the platform's standardized base mesh and blend shape system.
So an artist can focus on creating a stunning, unique face, and the software handles the complex engineering to make it actually work with the platform's AI.
Exactly. It effectively removes weeks of highly technical rigging work for the average creator. And once the digital human is designed and rigged, the toolkit includes a complete testing and publishing environment.
And this is where you iterate on the behavior layer.
It's crucial for that. Creators can use real-time voice input to test the digital human's response, observing how the motion synthesis engine interprets their tone and semantics. This immediate feedback loop allows refinement, making a character's response to confusion less aggressive, or their teaching mode gestures more expansive.
And the publishing side, I see, includes a dashboard with transparent analytics on sales, engagement, and most importantly, quality ratings. That transparency is essential to maintain creator trust in that 70-30 split.
For sure. And the monetization flexibility reflects this creator-first philosophy. Creators can choose from a huge range of pricing models.
Right, you see everything from microtransaction pricing, like a one-time purchase of $99 for a basic fun companion, all the way up to highly specialized offerings at $999 or more for a licensed professional assistant, say a chartered accountant with specific LLM training.
And subscriptions are also available, which makes perfect sense for services that have ongoing LLM query costs and continuous infrastructure demands. Monthly payouts are guaranteed, supported by that transparent analytics dashboard, and the platform handles all the complexity of global payment processing, currency conversion, and tax compliance.
It all just lets the creator focus purely on product development.
Exactly. Finally, there's a marketplace experience for the end user. It needs to feel robust and trustworthy to justify buying a persistent AI companion.
So what's that like?
It's designed like a premium software storefront. Users can browse and search by function companion, tutor, specialist, productivity assistant, and it's all backed by detailed user ratings and reviews. And to address the risk of buying a complex AI personality, the sources emphasize the importance of free trials.
That makes sense. Typically allowing limited interaction, maybe 10 to 20 messages, just to gauge the personality, the voice, the responsiveness before you actually commit and buy.
And thanks to that standardized backend and the ubiquitous sync architecture, activation is instant upon purchase. You buy the digital human, you log in with your single identity, and she is immediately available across all your compatible devices.
Which brings us to the real technical meat of this deep dive.
Okay, here we go. This is the section that truly defines the platform's technical mode, solving that real-time natural movement problem. Let's start with the motion synthesis engine. How exactly did they bypass this decades-old problem of stiff, uncanny movement?
They moved away from rigid, rule-based systems and they went toward generative AI. They used diffusion-based gesture generation, which is directly inspired by state-of-the-art research in synthesizing human movement from multimodal data.
Okay, so for listeners who might only know diffusion models from image generation, like Midjourney, how does a diffusion model apply to generating movement? It's a powerful analogy. In image generation, the AI starts with random visual noise and it slowly refines it until it matches your text prompt. Here, the process is similar. The AI starts with a cloud of potential motion data, like a sequence of random poses, and it iteratively refines that motion until it satisfies all those complex input conditions we talked about.
The text, the emotion.
Right, the semantic meaning, the vocal rhythm, and the emotional tone. It learns from massive data sets of real human conversation and gestures to understand the probabilistic likelihood of a certain hand movement accompanying a certain phrase.
So it's not looking up a canned hello wave, it's generating a brand new, contextually appropriate motion sequence on the fly.
Exactly, and this is why they need a multimodal fusion architecture. The engine doesn't just read the text, it takes simultaneous continuous inputs. First, text, the LLM's output, giving it the core semantic meaning.
Got it.
Second, audio prosody, the rhythm, pace, pitch, and volume of the synthesized voice. Third, an emotion vector, a continuous numerical reading of the intended emotional state, excitement, caution, neutrality.
And the fourth is the context.
The fourth is conversational context, the history and environment, which affects formality and gesture size.
Fusing those four elements allows the AI to produce those semantically coherent gestures. The difference between the digital human saying, "There is zero possibility of that," with casual shrug, versus saying the same phrase with an emphatic, open palm gesture to match the urgency.
And this needs to happen with blinding speed. The performance targets are what truly separate this from academic research. They are aiming for continuous gesture output at 60 frames per second, FPS.
Which is essential for perceived smoothness.
Absolutely. And they mandate a target inference time of less than 50 milliseconds for the motion generation itself. That aggressive latency target is crucial because the overall system latency, LLM response time, network delay, TTS generation, is already substantial.
So if the gesture generation takes too long, the movement will lag behind the speech, and you instantly get that soulless, uncanny effect.
You've got it. By optimizing motion to under 50 meters, they effectively hide the latency of the other, slower components, which makes the digital human feel responsive and alive.
Okay, so moving to the graphics and rendering pipeline, they talk about upholding standards for realism everywhere.
And this is where that standardization really pays off. They enforce the use of the ARKit52 blend shapes and high-fidelity base meshes. This ensures that the generated motion output, which comes out as a standard animation data stream, probably in BVH format, can be universally applied across all the creator models without visual glitches.
They're standardizing the puppet so they can focus on perfecting the puppeteer, which is the AI motion engine.
Perfect analogy.
Yeah.
And the required rendering optimizations are significant, given the goal of ubiquity. We're talking about real-time, physically based, rendering PBR materials, dynamic lighting, complex shaders, all to achieve photorealism.
And they have to manage that workload across all kinds of devices.
To do that, they set tiered performance targets, a high-end 60 FPS on desktop, and a still very demanding 30 FPS on mobile devices. To achieve this consistency, they use platform-specific optimization pipelines. That means using WebGL for browsers, Apple's Metal API for iOS, and Vulkan or DirectX for high-performance desktop and compatible Android systems.
So no one-size-fits-all rendering?
No way. The final subtle piece of this section is the two-stream approach for facial animation. This sounds like a sophisticated compromise between speed and detail.
Ah, so it's a clever division of labor.
It is. It's a hallmark of good engineering. Think of it like this. Stream 1 is the fast deterministic stream. This handles the core lip synchronization, the essential task of mapping phones, the speech sounds, to the corresponding blend shapes. This is low latency, computationally cheap, and deterministic. It ensures the mouth always matches the words perfectly.
Okay, so that's the mechanical part.
Right. Then Stream 2 is the higher-level intelligent generator. This is AI-driven and focused on the subtle, non-linguistic microexpressions. The eye movements, the slight frown of concentration, a nervous lip curl, all driven by the emotional and contextual inputs from that multimodal fusion architecture.
So Stream 1 handles the robotic requirement, saying the words correctly, and Stream 2 handles the humanizing subtlety. Separating them ensures the core communication isn't delayed by the complex computational effort required for the micro-expressions.
Precisely.
Okay, so they've solved the problem of making the digital human move naturally and quickly. Now we have to tackle the truly pervasive element, making her follow you everywhere.
And this section, this is what defines a platform's utility and its long-term stickiness. The context synchronization system is what transforms a highly sophisticated avatar into a persistent, integral part of the user's life.
This has to be the ultimate killer feature. Without it, every interaction feels fragmented, like a clean slate. The promise is one assistant, one memory, one continuous relationship, whether you're talking to a phone screen or a smart fridge.
And this places enormous demands on the back-end infrastructure. They set an incredibly stringent performance goal, syncing the entire real-time state across every single connected device in under 100 milliseconds.
Sub 100 meters global synchronization. I mean, traditional database architectures just won't cut it. You need massive distribution and near instantaneous state propagation.
You do. This points directly to the use of a highly distributed, globally replicated database solution. The documents hint at something like Cassandra or MongoDB, which excels at high volume, low latency writes, and eventual consistency that's fast enough to feel immediate.
And it has to handle a continuous stream of metadata, not just the dialogue.
Right, not just the text, but device type changes, location shifts, and micro updates to the user's emotional state.
So let's define exactly what's in the context structure. What is this data packet that is following the user around?
It's a complex, multi-layered structure that enables true personalization. First, you have memory, which is tiered. Short-term memory captures the immediate past, the last 100 conversational turns, and the verbatim transcript. This is essential for conversational continuity. Then long-term memory is the summarized abstracted history, the learned user preferences, recurring habits, interests, summarized project notes. This is where the AI learns who you are over months and years.
Okay, after memory, there's the environment context.
This is critical for behavioral adaptation. It includes real-time data like time of day, current weather, and most importantly, the location-aware context. Are you flagged as being at home, in the office, in your car, or in a public space? This dictates everything from tone of voice to the automatic implementation of privacy protocols in shared environments.
And finally, the user profile.
This contains static and dynamically learned information, tastes, habits, relationships, like who your spouse or manager is, the specific device type currently being used, and the current privacy level requested by the user.
This is best illustrated through the scenario they provided, the Amy example, a day in the life. I think we need to walk through this in detail to really appreciate the power of continuous context sync.
Let's do it. Let's track Amy, a highly capable digital human assistant, from morning to night.
The day starts at 7:00 a.m. in the kitchen. The user approaches the smart mirror. Amy appears instantly. The system syncs the environment context, home, 7:00 a.m., and checks long-term memory, known sleep patterns.
And Amy doesn't just give a generic greeting, she's contextual. She says, "Good morning, you only got 6 hours of sleep last night. Let's keep today efficient. Your preferences show you love a fast, healthy breakfast. Would you like me to start the shopping list for the ingredients needed for that avocado toast recipe you tried last week?" The memory sync is continuous.
That's amazing. So the user confirms the toast and says, Amy, remind me to look up that new negotiation podcast everyone is talking about on the drive.
The scene shifts. It's now 8:00 a.m., and the user's in the car looking at the Android automotive display. Amy appears on the screen. The context sync updates. Location is commute. Activity is driving. The tone automatically shifts to be less visually intrusive and more auditory focused.
And Amy immediately addresses the request logged an hour before. I've queued up that negotiation podcast starting where you left off yesterday. I also see, based on your calendar, that you have a crucial Q3 budget meeting at 9 a.m. Traffic is heavy. I've adjusted your speaking volume for road noise.
The user is listening and has a sudden realization. Amy, take a note. The Phase 2 timeline needs to be contingent on legal review, not just budget approval. And Amy instantly logs this thought using short-term memory and the task manager component of the context structure.
Okay, now it's 9:00 a.m. at the office. The user sits down at their desktop PC. Amy appears on the screen edge, likely in a more professionally attired state, which is defined by the behavior rules in the office context. The sync is complete in milliseconds.
And Amy knows the exact conversation that just happened in the car and the current activity, which is reviewing a budget document. Right before the meeting starts, Amy surfaces the key task. Before you jump into the meeting, just a reminder about the note you made during the Drive Phase 2 timeline contingent on legal review.
But it gets better.
It does, she continues. Also, based on our long-term records, the Q1 budget review was flagged for underallocating server infrastructure. Should I flag that in the meeting notes now?
That is powerful. She's not just a reminder, she's an active, data-informed advisor leveraging long-term memory about past failures and successes.
Exactly. So later that day, 6:00 p.m., the user stops at the grocery store. They log in via a QR code at a supermarket kiosk. Amy appears. Context update. Location is public retail. The digital human's privacy settings automatically activate, limiting the display of highly personal info.
Right.
But she can still access the shared shopping list data.
So Amy says, welcome back. You're making pasta tonight and you're running low on milk and that specific artisanal cheese you like. Based on your current location, the milk aisle is 2 aisles over. The system is actively cross-referencing the shopping list with the location, turning her into a functional, localized guide.
And finally, 8:00 p.m. back at home. The user is relaxing in front of the smart TV. Amy appears, maybe overlaid subtly on the screen. Context: home, evening, activity, leisure.
Amy transitions to the companion role. It looks like you had a productive day, but a long one. Shall we watch that new sci-fi series you added to your list? And just a gentle reminder, we logged that 9:00 a.m. bedtime goal for peak cognitive performance tomorrow, so let's wrap up by 10.
The key differentiator is just indisputable. That is the same Amy on 7 or more devices, adapting behavior and tone, and most importantly, maintaining continuous conversational context and memory. That seamless handoff, guaranteed in under 2 seconds, is what makes this feel like a singular, persistent entity rather than a series of disposable interactions.
Achieving that level of global, real-time sync and fault tolerance requires some serious engineering mastery. Let's pivot to the deep structural details they provided about their robust back-end infrastructure.
They've made very specific choices that prioritize reliability and massive scalability. For the control plane, the systems managing the millions of simultaneous digital human sessions, they employ architectural principles inspired by Erlang OTP and Elixir-style pods.
Okay, why choose that specific, highly specialized concurrency model?
Because of its inherent properties of fault tolerance and supervision. In this model, each digital human instance is treated as a supervised tree of lightweight, isolated processes. If one user's interaction crashes because of a sudden network drop or a bug in a creator's custom logic, that specific process can be instantly restarted, completely isolated from the rest of the system, without impacting the core platform or any other running digital human.
It ensures continuous service availability and robustness, even under extreme load.
That's the idea. Now let's look at the runtime and logic for the custom creator behavior. They run this using a Rust runtime compiled to WASM, WebAssembly, in a sandboxed environment. This is a very significant technical choice
Why is this significant?
because it solves two major related problems, security and portability. Creators are uploading their proprietary behavior logic, which often includes specialized LLM prompt rules and custom workflows. By compiling this logic to WebAssembly, OpenHuman can run it in a secure, sandboxed environment. This prevents malicious or buggy creator code from escaping its container and compromising the data of other users.
And portability.
WASM is designed to run efficiently across virtually any platform cloud servers, edge devices, even within a browser itself. This makes the creator's logic highly portable and allows OpenHuman to deploy that behavior engine wherever the user is, maximizing low latency performance.
And the context store, as we established, requires global distribution, relying on distributed databases like Cassandra or MongoDB to guarantee that vital sub-100 meters real-time sync.
And this entire infrastructure is predicated on strict security and compliance. The sources stress end-to-end encryption for all conversation and context data, mandatory adherence to global data privacy laws like GDPR and CCPA, and crucially, transparent user data ownership and export rights. This is essential for building trust in an ecosystem that demands access to every part of your life.
The scope of deployment, the ubiquitous device support, is what justifies this massive back-end effort. They need to be everywhere the user is, which is why that context sync is so critical.
The SDKs cover the full spectrum. iOS using Swift and ARKit, Android using Kotlin and AirCore, web via WebGL, and dedicated desktop support via Electron. But they specifically target the emerging markets of embedded devices, IoT, smart mirrors, fridges, and the automotive space using Android Automotive.
And they even include the public sphere, aiming for integration into public kiosks in malls and airports.
This wide deployment is the foundation for their long-term vision, the ultimate goal of OpenHuman.ai.
And what a vision it is.
It's transformative, and it's captured in one powerful statement they make. In 10 years, people will not interact with apps. They will interact with beings. They see the digital human, the persistent, embodied entity, as the ultimate future operating system interface.
So they want to be the operating system and marketplace for these persistent, multimodal, cross-device AI beings. This fundamentally changes the user's relationship with technology from operating a tool to engaging with a companion.
And the potential applications are boundless because of the guaranteed persistence and natural interaction. We move beyond simple personal assistants to truly empathetic customer service avatars, personalized 247 educational tutors, and even complex healthcare companions that can monitor wellness and provide continuous emotional and informational support.
And none of that is truly possible if the AI is constantly forgetting who you are and where you are.
Exactly.
This has been a true deep dive into the engineering and business strategy of OpenHuman.ai. Let's consolidate the essential takeaways for our listener.
I think there are two foundational pillars underpinning OpenHuman.ai's entire structure. First is that crucial AI breakthrough in natural, real-time motion and gesture generation, leveraging diffusion models to overcome the final bottleneck. This is the technical achievement that moves digital humans out of the uncanny valley, making them genuinely feel alive with semantically coherent movement at high frame rates.
And second, the architectural breakthrough in persistent cross-device context synchronization. This is the global infrastructure that guarantees the continuity of relationship and memory, making sure that the digital companion you purchase follows you from your smart mirror to your car display and everywhere in between, with handoffs occurring in, less than 100 milliseconds?
Right. OpenHuman.ai is making a bold existential bet that the most intuitive and effective interface for the next generation of complex AI isn't the chatbot, not the static voice, but a photorealistic, embodied human presence. And if they succeed in standardizing the quality of this digital human using standards like ARKit blend shapes, and if they successfully incentivize mass creation via that compelling 70-30 revenue split,
Then we are looking at the foundational moment for a new kind of digital economy. An economy where the AI entity itself is the application, standardized, reproducible, and ready to be integrated universally.
and this leads us to the final provocative thought. OpenHuman.ai's success relies on the deep personalization and continuous presence of these beings. If the platform achieves this ubiquitous, persistent reality, and the creator economy flourishes, what will be the social, the psychological, and the relational implications of having highly specialized, emotionally responsive, and deeply knowledgeable digital companions that are always truly there? The ultimate question is not about the technology, but about the new forms of digital companionship and life that will inevitably emerge from this open ecosystem.
A future that feels much closer now. Thank you for joining us for this deep dive into OpenHuman.ai. We'll see you next time.